Hello students, in this video we'll discuss third chapter of physics of 9th standard, that is laws of motion. So in A part, contact and non-contact forces is mentioned. So in this we will try to discuss contact and non-contact forces in detail. First we'll try to discuss the effect of force. So two kind of effect we can notice. One is the force can change the state of rest or of motion of the body, and it can produce motion in the body if it is at rest, and if it is already in motion, so by applying the force we can bring that body into rest. In daily life, number of examples are coming across. Like first is, if we'll apply push on the ball will continuously move in forward direction, and under the application of frictional force finally it will come to rest. Pull exerted by the steam engine moves a train, and even the ripened fruit will fall down because of the gravity. Second is, it can change the size or shape of the body. It can change the dimension of the body. So by loading a spring hanging from a rigid support, you can notice that the length of the spring will increase, and even by hammering a small piece of the silver sheet, we can turn out that silver sheet into a thin foil. So here we can notice that the size as well as the shape of the body can be changed by applying the force. Now there is an important note regarding the rigid and non-rigid object. So in the rigid object, which is solid and will not change its interspacing between its constituent particles, and under the application of the force we can bring only motion in the rigid body. We can't change its dimension. But on the other hand, when the force is applied on the non-rigid object whose interatomic or interspacing can be changed, so under the influence of the force we can bring motion into it, and even we can change the dimension as well as shape of the body. So here is the definition of the force. The force is the physical cause which changes or tends to change either the size or the shape or the state of rest or motion of the body. Further kinds of forces, two kinds are there. One is contact forces and other one is non-contact forces. Under contact forces, as the word is there, the forces which are applied on the bodies by taking a physical contact with them, such kind of forces are called contact forces, right? Some examples are there. Force of friction, there also we need contact. Normal reaction force, there also we need contact. Third one is force of tension and force exerted by spring, force exerted on two bodies during collision. So one by one we will discuss. First, frictional force. As you can see, this book is lying on the table, and book surface and table surface, they are in contact. So when I try to push this book, an opposite self-adjusting force which is called friction force will try to oppose the cause of motion. So it will act in opposite direction of the motion. So this is a kind of contact force. Second is normal reaction force. You can see here very nice diagram is given. A block is balanced on the palm. So the weight of the block is acting on the palm, and palm is providing support to this block. Okay, so that is a kind of reactionary force, normal reaction, which is equal to the weight of the body, but it acts in opposite direction, in upward direction, and weight is acting downward. So this is also a contact force. Third one is tension force as applied through string. So you can notice over here, as the weight is suspended with the help of the string and one end is fixed with the rigid support, so weight is acting downward and tension is acting along the length of the string and towards the point of suspension. So force of tension magnitude is also equal to the weight, but direction is opposite. So this is also a kind of contact force. Now the fourth is force exerted by the spring. As you can see, this is the simple diagram of the spring. Here we are pulling this spring, so the length of the spring will be elongated and a restoring force will try to act in opposite direction. Okay, and when we will push it, the length will become shortened, it will compressed, but restoring force will start acting in opposite direction. So this is also a kind of contact force. Fifth one is force exerted during collision. Now you can see here two bodies, one is the bigger one, other one is the smaller one, both are approaching to each other. Finally they will collide, and under the influence of this collision, FAB is the force acting on A due to B, and FBA is the force on B due to A, will act in opposite direction. So finally the motion of the A will become opposite, it will start moving towards left side, and B motion will also become opposite, it will start moving towards right side. Now non-contact forces, as the name is there is not any requirement of physical contact. So the force experienced by the bodies even without being physical touched or contact are called non-contact forces, and these forces start acting at a distance. Examples are gravitational force, electrostatic force, and magnetic force. Now gravitational force is because of the mass, and gravitational force is a kind of force which is always attractive in nature. Second one is electrostatic force. So these are the force because of the charge. If two like charges are in under the consideration, so two like charges always repel each other and two unlike charges always attract each other. It can be repulsive, it can be attractive. Example for the gravitation: a coin falls down when it is released at a height. A body, when it is thrown up in air, it goes up under the influence of initial velocity. Finally the velocity will become zero, and then it will start coming towards the ground because of gravity. Example of electrostatic force: when comb is rubbed on a dry hair, it gets charged, and even you can bring that electrified charged comb near to the small bits of paper. What you will find? Small bits of paper will get attracted towards the electrified comb. Now magnetic force, this is also a kind of repulsive and attractive force. When like poles means north and south of a magnet, when we will observe them, what we will find? They will start repelling each other, and unlike poles always attract each other. Now general character of non-contact forces: first one is gravitational force is always attractive in nature. As I told you, force of gravitation is always attractive. Okay, but magnetic force can either attractive as well as repulsive. Same case with the electrostatic force. Second one is magnitude of non-contact forces on two bodies that depends on the distance of separation between them. It decreases with the increase in separation and increase as the separation decreases. So in this, force of gravitation is directly proportional to the product of masses and inversely proportional to the square of the distance between these two masses. This directly proportional sign, if we replace with equal to one constant of gravitation, that is capital G. So the final name of this is universal gravitational constant. In the last part we will discuss force of gravitation in detail. So this is the final expression of force of gravitation, that is equal to G m1 m2 upon r square. Similarly, force which is electrostatic, that is directly proportional to q1 q2 product of charges and inversely proportional to the square of the distance between these two charges. This directly proportional sign, if you replace with equal to one constant of proportionality, we have to introduce, that is k. So F electrostatic is equal to k q1 q2 upon r square. So these formulae you can keep in mind, so it will help you while solving the numericals. Thank you.